7.4, adding and subtracting rational functions. The idea here is to get a common denominator and add the numerators. So when you have a problem where they have the same denominators, you simply just add the numerators or subtract the numerators, such as these examples. If the denominators are the same, you add the numerators. Same thing here, subtract. Now, if this happened to be some sort of expression, you'd have to distribute that negative through, and that could be the only mistake on that type of problem. Same idea here. You have 3 over 12x. So this answer would be 3 over 12x. But remember, you can simplify that to 1 over 4x. So you always look and see, is there one more step that you can do to simplify, such as that 3 going into the 12. But sometimes the denominators are not the same, and if they're not the same, you have to find the least common multiple of the denominators. So for example, if you're looking at, if these two were denominators, you would factor both of them and see what's in common. And so you would see in this one, after you completely factor, it looks like that, and this one looks like this. And then you look and see what is in common and what is not in common. So you can see that there's a 4 and a 6. So what's in common is just a 2. So what I'd like to do is just pick the larger one and do multiples of the larger one until the smaller one goes into it. So 6 times 2 is 12, 4 goes into 12, so I'm going to put a 12 here for the least common multiple. And I'm going to see there's an x minus 2. That's already in both of them. And then I have an x plus 2 and an x minus 2. So there has to be another x minus 2 what's shared. So now I can see that this whole thing will go into this, but now I have this x plus 2 in this one that's not shared. So if you look at this whole least common multiple, can this expression go into it, and can this expression go into an even amount of times? And the answer is yes. So where does that occur in problems? Where there's a sum and a difference. So the first thing that you would do is factor and see what you're looking at in terms of least common denominators. Now, again, there's, if you could, least common multiple, least common denominator, same idea. You can see that there's going to be a 9. 3 goes into 9 even amount. And then there's going to be an x squared because x goes into x squared. And then what's left over is x plus 1. So now what you know is what you have to multiply by in order to have the same denominator. So I want to multiply by x plus 1 on the top and the bottom. And I want to multiply by, let's see, it's going to be 3x on the top and the bottom. Once you do that, I'm going to go ahead and distribute on the top. And then on the bottom, you're going to keep factored form. So 9x squared times x plus 1. The reason why you keep it in factor form is because it's possible that you may have some sort of a cancellation at the end. Okay, 3x squared plus 7x plus 7 over 9x squared times x plus 1. And now you're always going to see, can you actually factor this? So let's see, I would think that I probably can't. It has to be 3x and an x to get the smallest number. If I put a 7 here, it's already going to be at 7, and it's only going to be more than that. So no, I can't get it going further than this. It doesn't factor. So that is my answer after I add. Again, always check and see if you can factor. If you can factor and there's a cancellation, then you would be able to simplify it. Finding the difference. Okay, so in this problem, again, always start with factoring. X minus 1, x minus 3. So you know that I think what I can also do to make this problem easier is I can go ahead and say this is going to be a plus negative this. Now, when that means that I can simplify the top too. When I distribute that negative through, I now am going to have that, which makes all those pluses instead of negatives. It makes it a lot easier. Okay, so what do I need to do in order to get a lowest common multiple? There has to be a 2 here, and that covers this one right here. This is going to divide into this. What about the other way around? Well, I need the x minus 3 here. Okay, so at this point, I'm going to go ahead and multiply the 4 times. So it's x squared minus 3x, and then it's going to be plus 2x minus 6. And I want to distribute the other one, plus 4x plus 2 all over, again, keeping it in factored form. I usually put the numbers out front so they don't get lost. Looking at my x squared, I have x squared. There's only one of them. This is minus x plus 3x and minus 4 over 2x minus 1, x minus 3. Now you're always trying to check again, can you factor? This is the fun part because you can maybe simplify it down and make it look nice and pretty. So this is x and x plus 4 minus 1. 4x minus x is 3x. Yes, that does work. And yeah, look at that. You can cancel those x minus 1s, and you're ultimately going to get x plus 4 over 2 times x minus 3. Now, the only other idea here is when you have a complex fraction, you're still looking to see what is the lowest common multiple. And when you find the lowest common multiple, you're going to multiply the top and the bottom by that. And so in a way, it's x times x plus 4 over x times x plus 4. And notice that it's really over 1 to line up with these. But sometimes that makes it more complicated on what you're trying to do. But just make sure it's just x times x plus 4 over x times x plus 4. And then you distribute through and see what you get. Now the x plus 4 is canceled, so on the top becomes 5x. That's it. On the bottom, x plus 4 is canceled. You're left with x. Distributing it to the next one, x is canceled, and you're left with plus 2x plus 8 equals 5x over 3x plus 8. Can't factor, so that's the end of your answer. Again, the idea is to multiply by the lowest common multiple over the lowest common multiple to get rid of all the fractions within the fractions.